Okay, so problem 4 is SPICE, which is a scheme problem. And it starts off with a definition that a repeated call is a nested call expression in which each sub-expression is either a number, a symbol, or a call with exactly one operand. And then our task for part A is to implement repeated call, a procedure which takes an operator expression and a list of operand expressions, and then it returns a repeated call for the operator and operands. And then it has this kind of base case where if operands is nil, then the result is going to be the operator expression. So it looks like they've already defined that base case here, which means that in order to finish the implementation of repeated call, we just have to fill out what the recursive case should be. Okay, so since repeated call is kind of like a complicated concept, first let's just walk through the doc test and see what exactly repeated calls are. So repeated call takes, first of all, the function. It takes in two arguments. One is the operator and one is the operands. And then what it's going to return is it's going to return a function call of the operator on the first operand, and then that's going to hopefully evaluate to another operator, which is going to be called on the next operand, and then which is going to be called on the next operand, etc. Okay. So in our recursive case, in order to kind of go through this sort of syntax, it'd be helpful to look at how we can solve just one step of the problem. And what I mean by one step is, for example, if we have our original doc test where we have our operator be f and then our operands be a list of 2, 3, and 4, well, let's just see how we can apply f on 2, and then we can recursively call all of this on the 3 and 4. So we can worry about 3 and 4 later, but first let's just figure out how we're going to call f on 2, and then that's going to be our operator for our next recursive call, and these are going to be the operands. Right? So in order to fill out these blanks, we know that first off we're going to have to make a recursive call onto repeated call, right? This is kind of just guaranteed. Repeated call. And what we really need to figure out is what are going to be the operator and operands for our recursive call. Well, if we just look at, again, like the first step, you can figure out what the operator is by looking at what exactly these two values are. So f is actually just our original operator, so it's going to be operator. And then 2 is the first element of our operands. So this is going to be car of operands. Now, this should all be in a list, right? Because if you remember, this is like the sort of first recursive call, and that will be our operator for the subsequent recursive calls. And this is all inside a list. So I'll just put this inside a list like this. And that should be our operator. Cool. So now what is operands? Well, in this example, operands is going to be 3 and 4, essentially what's left of operands, where you already used that 2. So you can get that by essentially getting the cdr of operands so far. So this would be cdr of operands. Sorry, that's not scheme syntax. Cdr of operands. And that should give you the operands for the recursive call. Cool. So now just kind of filling in these blanks, A should be a repeated call, because that's our recursive case. B should be a list containing the operator and car of operands. And then C should be the cdr of operands, so right here. So all in all, what we're doing is we're defining our recursive case, where essentially our leap of faith is that calling repeated call on operands, like a smaller subset of operands, is going to do exactly what we want. So really we just need to worry about how do we take that first step. So our first step is to combine the f and the 2, like shown right here, into our operator, because that's going to be our operator for our subsequent recursive calls. So in order to merge the two, we made a list containing operator and the car of operands, which is the first value. And then what we have to recursively call it on is the rest of the operands, which is just going to be coulter of operands. So hopefully that makes sense why we filled out each of the blanks the way we did.